Science at its core is a journey of exploration, a relentless pursuit to understand the intricate workings of the universe and our place within it. It is a quest that transcends borders and cultures, uniting humanity in a shared endeavor to uncover the truths that govern our existence. It's a tapestry woven from curiosity, observation, and the rigorous testing of ideas. Each thread represents a question asked, an experiment conducted, and a discovery made. This intricate fabric of knowledge is ever expanding, with each new finding adding to the richness of our understanding. Science is driven by a fundamental human urge to seek answers, to unravel the mysteries that surround us. From the vastness of the cosmos to the minute particles that make up matter, every aspect of the universe holds secrets waiting to be discovered. This quest for knowledge is what defines us as a species, propelling us to explore the vast expanse of space and delve into the microscopic world of atoms. It is a journey that requires not only intellect, but also imagination and creativity. Unlike dogma or blind belief, science embraces skepticism and doubt. It encourages us to question everything, to challenge the status quo, and to seek evidence before accepting any claim. This critical approach ensures that our understanding is based on facts and not on assumptions. It thrives on questioning established ideas and pushing the boundaries of knowledge. Every hypothesis is tested, every result scrutinized, and every theory subject to revision. This relentless pursuit of truth is what drives scientific progress. Every scientific theory, no matter how widely accepted, is subject to scrutiny and revision. This openness to change is a hallmark of science, allowing it to adapt and evolve as new evidence emerges. It is a dynamic process that reflects the ever-changing nature of our understanding. This constant questioning, this willingness to refine and even discard old ideas in light of new evidence, is what makes science a powerful engine for progress. It is a self-correcting mechanism that ensures our knowledge is always moving forward. Science is not about absolute certainty. It is about building the most reliable and consistent explanations based on the evidence available. This provisional nature of scientific knowledge is what makes it robust and adaptable. Instead, it offers us the most reliable and consistent explanations based on the evidence available. These explanations are always open to refinement and improvement as new data and insights come to light. It's a humble pursuit, acknowledging that our understanding of the universe is always evolving. This humility is what allows science to grow and adapt, constantly refining its picture of reality. The beauty of science lies in its ability to adapt and grow, constantly refining its picture of reality as new discoveries come to light. It is a never-ending journey of learning and discovery. The journey of science is never-ending. Each discovery opens up new avenues of inquiry, leading to further exploration and deeper understanding. It is a continuous cycle of questioning, investigating, and discovering. Every answer leads to new questions, urging us to venture further into the unknown. This insatiable curiosity is what drives scientists to push the boundaries of what is known and to explore the frontiers of knowledge. This ongoing exploration, this insatiable thirst for knowledge, is what lies at the very heart of science. It is a testament to the human spirit and our unending quest to understand the world around us. Science rests upon two fundamental pillars, empiricism and rationalism. These two approaches have shaped the way we explore, understand, and explain the natural world around us. They are not just abstract concepts, but practical methodologies that scientists use every day in their quest for knowledge. These principles guide our understanding of the natural world and help us distinguish between knowledge and belief. They provide a structured approach to inquiry, ensuring that our conclusions are based on solid evidence and logical reasoning. Empiricism emphasizes the importance of observation and experimentation. It is the idea that knowledge comes from sensory experience, and that we must rely on what we can see, hear, touch, taste, and smell to form our understanding of the world. It tells us that true knowledge must be grounded in the evidence we gather through our senses. This approach has led to countless discoveries and advancements, from the microscopic world of cells to the vast expanse of the cosmos. Scientists carefully design experiments to test their hypotheses, meticulously collecting data to support or refute their ideas. This rigorous process ensures that the conclusions drawn are reliable and can be replicated by others. Rationalism, on the other hand, stresses the power of reason and logic in shaping our understanding. It posits that the mind can grasp certain truths directly, without the need for sensory experience. Scientific theories are not merely collections of facts. They are logical frameworks that connect and explain those facts, providing a coherent picture of how different phenomena are related. They are logical frameworks that connect and explain those facts. Rationalism allows scientists to develop models and theories that can predict future events and explain past occurrences. Scientists use deductive reasoning to draw predictions from their theories and inductive reasoning to generalize from specific observations to broader principles. This dual approach helps in building a robust body of scientific knowledge. The interplay between empiricism and rationalism is crucial to the scientific process. Neither approach alone is sufficient. They complement each other, creating a balanced methodology for scientific inquiry. Empirical data, gathered through observation and experimentation, provide the foundation for scientific theories. These data are the raw materials that scientists use to build and test their ideas. Rationalism then provides the framework for interpreting those data and constructing coherent explanations. It helps in making sense of the empirical evidence, allowing scientists to develop theories that can be tested and refined. This dynamic interplay ensures that scientific knowledge is both grounded in reality and logically sound. It is a continuous cycle of observation, experimentation, reasoning, and refinement. However, it's important to remember that both empiricism and rationalism have their limitations. No method is infallible, and both approaches can be subject to errors and biases. Our senses can be deceived, and our reasoning can be flawed. This is why science places a strong emphasis on verification and peer review. Therefore, science embraces skepticism and critical thinking. Scientists are trained to question their own assumptions and to critically evaluate the evidence before them. Scientists constantly question their own assumptions and biases, seeking to eliminate errors and refine their understanding. This rigorous scrutiny helps to ensure that scientific knowledge is as accurate and reliable as possible. This self-correcting nature of science is what sets it apart from other ways of knowing. It is a dynamic and evolving process, always striving to improve and expand our understanding of the universe. The scientific method is often portrayed as a rigid, linear process, a step-by-step guide that leads to definitive answers. This portrayal, while useful for educational purposes, oversimplifies the true nature of scientific inquiry. However, in reality, it's a much more fluid and iterative approach to understanding the world. Scientists often find themselves revisiting earlier steps, refining their methods and rethinking their hypotheses based on new data and insights. Think of it as a dynamic blueprint, guiding us through the exploration of the unknown. This blueprint is not set in stone. It evolves as our understanding deepens and as new technologies and methodologies emerge. While specific steps may vary depending on the field of study, the underlying principles remain constant. Whether in biology, physics, chemistry, or any other discipline, the core of the scientific method is about seeking truth through evidence and reason. The journey often begins with observation, a curious mind noticing a pattern, an anomaly, or an unexplained phenomenon. This initial spark of curiosity is the driving force behind many scientific discoveries. This sparks a question, a desire to understand the why or how behind the observation. Questions like, why does this happen, or how does this work, are the seeds from which scientific inquiry grows. From this question, a hypothesis emerges, a tentative explanation that can be tested. This hypothesis is a crucial step as it provides a focused direction for the research. This hypothesis isn't simply a guess. It's an educated speculation rooted in existing knowledge and theories. It draws upon what is already known to make a reasoned prediction about what might be true. It's an educated speculation rooted in existing knowledge and theories. Scientists review literature, analyze previous studies, and use their expertise to craft a hypothesis that is both plausible and testable. The next step involves designing and conducting experiments or observations to gather data. These experiments are meticulously planned to ensure that the data collected is reliable and relevant to the hypothesis being tested. This data then undergoes rigorous analysis, searching for patterns and relationships that either support or contradict the initial hypothesis. Statistical tools and computational methods are often employed to make sense of the data. If the data contradicts the hypothesis, it's back to the drawing board. This is not a failure, but a fundamental part of the scientific process. It means that the hypothesis needs to be revised or a new one formulated. The scientist revises the hypothesis or formulates a new one, restarting the cycle. This iterative process is what drives scientific progress, each cycle bringing us closer to a more accurate understanding of the phenomenon under study. Even if the data supports the hypothesis, the work isn't over. The findings must be carefully documented and presented to the scientific community for review and validation. The findings are shared with the scientific community, subjected to peer review and further scrutiny. This peer review process is essential for maintaining the integrity and credibility of scientific research. This process of open communication and critical evaluation helps refine scientific knowledge. Peer reviewers provide feedback, ask questions, and sometimes suggest additional experiments or alternative interpretations of the data. Over time, as evidence accumulates, a hypothesis may evolve into a theory, a well-substantiated explanation that has withstood repeated testing. Theories are the pinnacle of scientific understanding, representing the best explanations we have for complex phenomena. The scientific method is not a guaranteed path to absolute truth. It is a method of inquiry that helps us build a more accurate and comprehensive understanding of the natural world. It's a continuous cycle of observation, questioning, experimentation, and refinement. Each iteration brings new insights and often raises new questions, perpetuating the cycle of discovery. It's a journey driven by curiosity and governed by rigor, a testament to humanity's ongoing quest to understand the universe we inhabit. This relentless pursuit of knowledge is what makes science such a powerful and transformative force in our world.